In this video, we're going to approximate the area under the curve of this function of x equals to 100 over x plus 10 from x equals 0 to x equals 3 with 6 subintervals. Actually, it's just to put the sigma notation for right, left, and midpoint. Now, we can do one of this one, like let's say the left Riemann summation with the traditional notation, and from there calculate or write the left non-traditional, the right traditional, and the right non-traditional. And then we can verify doing all the work, etc. Well, if you think you can do it, stop the video now and next continue to see we have the same result. Alright, so the left Riemann sum is summation from I equals 0 to n of f of x sub I delta x. This is equal to summation from I equals 0 to n, to n of minus 1 of f of a plus delta x times I times delta x. This is equal to summation from I equals 1 to n. If we are up in here, we need to get down here. So f of a plus delta x I minus 1 times delta x, and this is that or summation from I equals 1 to n of f of x to I minus 1 delta x. Alright, so here, what's delta x? Remember the steps. First delta x, next x sub I, f of x sub I, and sigma notation. So delta x is 3 minus 0 divided by 6. Delta x is the wide of each rectangle. So this is 1/2. Now x sub I is, for the traditional way, is 8, that is 0, plus delta xi. So x sub 1 is 1/2 I. And so f of x sub I is 100 over 0.5 I plus 10. And so the sigma notation is summation from I equals 0 to n minus 1, so 5, of 100 divided by 0.5 I plus 10 times delta x, so times 1/2. Or you could say summation from I equals 0 to 5 of 50 divided by 0.5 I plus 10. Now, this is the traditional way. The non-traditional way would be sigma notation from I equals 1 to 6 of. The important issue is that here, this in f of x, the part in which we have x, that is this one, is where it's going to change. If we go up from 0, we are moving to 1. So this needs to get down 1 delta x. 1 delta x is 0.5. So would be 100 divided by 0.5 I. Instead of having plus 10, we will have 10 minus 0.5, because 1 delta x is 0.5. So, minus, because we are upping, so here we go down. So, plus 9.5 times 1/2, or 50 over 0.5 I plus 9.5. Now, the right Riemann notation, the traditional one, would be the same. The summation from I equals 1 to 6 of 50 divided by 0.5 I plus 10. And now the non-traditional right Riemann summation would be from I equals 0 to 5 of, here in the f of x, if we are getting down from I equals 1, now we are I equals 0, then this needs to go up. The part in which we have x, we need to put a extra delta x. So it will be 50 divided by 0.5i plus 10.5. Ready. And now if you want to do the midpoint, you use the formula summation notation. Summation notation from x equals 0, I equals 0 to n of f of a plus delta x times I plus 0.5, or summation notation from I equals 1 to n, so here is n minus 1, of f of a plus delta x times I minus 0.5. Remember that if we are upping here, we need to down one unit, one delta x unit. Alright, so yes, we go down from 0.5 to minus 0.5 is 1. Now, so here we have what's x sub I. X sub I is a is 0, 0, and delta x is 0.5, so we have 0.5 I plus 0.5. So f of x will be 100 divided by 0.5 I. 0.5 I plus 10.5. So this will be summation from I equals 0 to 5 of 100 divided by 0.5 I plus 10.5 times 1/2. Alright, and now it's 0.5 times 0.5, so it's 0.25. Sorry, here is 10.25. And the other one, so would be sigma notation from I equals 1 to 6 of 50 divided by 0.5 I, and instead of being 10.25 will be we got up 1 unit, so we need to get down 1 unit. 1 unit of delta x. Delta x is 1/2, so 10.25 minus 0.5 will be plus 9.75. So now if you want, you can do it as in the previous video when we do each one of the formulas, so you can do it to verify it. In the next video, now we are finally going to link the integral notation, the defined integral, with the sigma notation for Riemann summation.